Hello and welcome to my video where I talk about 2D vectors and especially components of 2D vectors. So we're going to break up and we can say that any vector can be broken up into two components, and usually we talk about a horizontal and a vertical component, although in a situation where we have an inclined plane we might not do that, and we'll talk about that in our next video. So here are two examples here. So let's try to use this idea of being able to break up vectors in order to find the components. So here's the first example. It's a pretty simple one. Mr. Drager flew south to Calgary. So south to Calgary, 300 kilometers, and then due west. Okay, pretend that this is possible. It's not true to, not actually true, but let's say it's due west to Vancouver. That's this direction, and it says the overall displacement was this direction of 600 kilometers from start to finish or end. Okay, so what was the distance from Calgary to Vancouver? So this is Calgary. I would like to use a different color. This is Calgary, this is Vancouver, this is Edmonton. Okay, so what is the distance from Calgary to Vancouver? So what we're going to do is just solve Pythagoras' theorem, just like in the last one, except that we're looking for a different portion of our components of our triangle. So we're solving for A instead of C, or B. Doesn't matter. B or A doesn't matter. But we're solving for one of those, not for C. So this will be C squared minus B squared equals A squared. Okay, so A squared equals, A equals the square root of both sides. So square root of C squared minus B squared. And so A equals, and so we're going to just plug this into our calculator. So 600 squared minus, what did they say, 300 squared? Yeah. I tried to make it roughly, approximately correct based off of what I could find on a map, but it's not exactly. But anyways, what is the distance from Calgary to Vancouver? 519. This is not exactly precise, but it gives a rough idea. So, and make sure that you're following sig-dig rules. So actually, hold on, I did not do that. So 519.6, and then you should round it to 520 kilometers. All right, wonderful. Okay, so that's a pretty simple example. Let's continue on to a more complicated one. Mr. Drager was pulling his kids in a wagon with a total mass of 26.3 kilograms. Okay, Mr. Drager pulled with a force of 75 newtons, and the handle was at an angle of 40 degrees to the ground. This is important. What is the total acceleration felt by the kids if the coefficient of friction was that between the wagon and the ground? Okay, I haven't tried this question out yet, so I don't know if the numbers are going to be reasonable, but let's see if they are. I always recommend pausing the video once you feel like you can try these questions out and seeing if you get the same answer that I do. All right, so hopefully you've tried this out. Here is what I would do. Always the same steps as the dynamics question. So start with your free body diagram. So you've got your wagon, okay, like this, and I'm pulling it. So I'm like over here, right? And I'm pulling it with a force, okay, that is force applied, which is 75 newtons. That's just straight up given to us. Okay, and that is 40 degrees to the ground. Okay, what other forces are there? There is the force of gravity down, there is the normal force up, and there is the force of friction in reverse, in opposing motion. Okay, just a couple things to mention. The force of gravity is mg. Okay, the force of friction is mu times Fn. This is in your formula sheet. Okay, so those are a few things to mention. This is our free body diagram. Okay, now that we have that, now we need to kind of work on trying to see what the total acceleration is felt by the kids. So what we need to do is we need to do an F net in the vertical, and we need to do a separate F net in the horizontal. Maybe I'll say, I'll do that in a different color. F net horizontal. And the A is also horizontal. Everything in here should be horizontal. Everything in here should be vertical. So keep track of that. Okay? And so this is equal to all the forces added up, but only in the vertical direction. And the red one is all the forces added up, but only in the horizontal direction. Okay, so let's take a look here at how this component idea will help us out. So this is a really common question. We've got a force at some weird angle. So the vertical force component of the force is this green part. And the horizontal component of the force is this red part. So how are we going to get it? Well, it'll be using SOHCAHTOA rules. So we've got, in the red part, we've got cos 40 equals adjacent over hypotenuse. Well, hypotenuse is 75. So it's 75 cos 40. Okay, same sort of process in green. We've got sine 40 equals opposite over 75. Well, that means we've got 75 sine 40 for our opposite. So that is our opposite. Okay, so now we're going to add all of those parts together. So all the regular forces I'm going to put in blue, and then I'll put the green special ones, the components, in red and green. So in the vertical direction, we have force of gravity, which is down, and that minus the normal force minus the force in the vertical direction. So because both of those are going up, they are opposing gravity together. Okay, and in the horizontal direction, we have, maybe we'll start with the red force, which is 75 cos 40, minus the force of friction, which I'll leave like that. Okay, now one really big thing to notice here is that our acceleration in the vertical direction is 0. So that means this whole thing equals 0. So we can rewrite that out as Fg equals Fn minus 75 sine 40. So far, so good. Now we can say, well, Fg is just mg. So Fg equals Fn minus 75 sine 40. Okay, this is important because what do we need to find right now? Well, we'll work on that, okay? If you don't see it yet, we'll work on it. Okay, let's look at the other part. Okay, maybe let's look at the red part, so the horizontal direction. Well, we're looking for the acceleration. So what we're going to do is we're going to go, hey, we're looking for that, so let's divide by m. Okay, and this part can stay the same, but the force of friction, I'm going to write it as mu times Fn. Do we know the Fn? No. We know the mu, we know the mass, we don't know Fn, so that's our one thing we need to find first. What do you notice? Hopefully you see that we have an Fn here. So actually let's solve for Fn in this version, or in this equation. So that would give us Fn equals, and maybe I shouldn't have moved stuff around until after, but Fn equals mg minus 75 sine 40. That means we can use this value as Fn over here. Okay, rewriting this out one more time, AH. Okay, AH equals 75 cos 40 over m minus mu times mg minus 75 sine 40. This is a very nice question because it's complicated and yet very simple. Right? Simple to draw, simple to understand, but you can see the algebra here is nice and complicated. Or, I don't know if you'd say nice and complicated, but it's beautifully complicated. Let's say it that way. Okay, so anyways, if we plug in all these values, we should get our acceleration. So I'm going to just show you guys how to plug this in to your calculator. So in my calculator and any other TI-84, I'd say use the fraction. So alpha, y equals, and then the first one gives you a fraction. Okay, so 75 cos 40 minus mu, what was mu? 0.4, I believe. Let's just double check. Yeah, 0.4. Whoopsies. 0.4 from the question. Bracket mass, which is 26.3, times acceleration due to gravity, which is 9.81, minus 75 sine 40, and another bracket. So that's the entire top, and then we're dividing by our mass, 26.3, and here is our acceleration. So I said that, well, here, let's write it down. Negative 1.006.244, whatever. So this is meters per second squared. Keeping in mind sig dig rules, this is negative 1. And we have only a single digit for coefficient of friction. So this is unfortunately where we have to leave it. Negative 1 meters per second. So squared. So what does this mean? In this situation, what does a negative value mean? Well, because we said, okay, and this is important, because we said that this force, which was this force, is positive, a negative acceleration tells us that it is deaccelerating. Okay, that means that I'm slowing down, I'm pulling less hard than friction is. All right. I hope this video helps you guys better understand components of 2D vectors, especially a more complicated example like the one at the bottom here. Yeah, so I hope this video helps, and good luck.